Hi, my name is Peter McTavish and welcome back to another DCG tutorial. In this tutorial we're going to do an early level question, and it's from the 2010 paper. It's a dynamic mechanisms optional question, C-4. Now I was asked to do this question. I hope this is the right one now, and we'll see how we get on. So read through the question first as always and know exactly what the question is asking for. So the 3D graphic on the right shows a pull-along toy. A cam and inline knife edge follower are used inside of the toy to move the head up and down as the toy rolls. The cam with a minimum radius of 300 or 30 mm, a camshaft diameter of 20 mm, and rotates in an anti-clockwise direction. The cam imparts the following motion to the follower. 0 to 120 degrees is a rise of 40 mm with uniform velocity. 120 to 180 is dwell, and 180 to 360 is a fall. 40 mm simple harmonic motion. Draw a displacement diagram and the profile of the cam. So first things first, to see what direction is it rotating. It rotates anti-clockwise. So it's rotating anti-clockwise between the first few points over here on the right. So what I'm going to do is I'm going to put in the details of the cam first on the right hand side. So by details I mean I'm going to put in the camshaft and the minimum radius. Camshaft has a diameter of 20 mm, so that's a radius of 10. And your closest approach was a radius of 30 mm. So if you put in a radius of 30 mm, your knife edge follower, the closest point you'll get to your center is there. And that just happens to give you not only the first point in your cam but also the height for your displacement diagram. So we're going to bring that over to the left now and start our displacement diagram. So that's the center there, it is rotating anti-clockwise, and that's going to be first point on your cam. So bring that height over to the left hand side and you start doing your displacement diagram. So let's pick a point far enough out here over the left so you stay out of the way of your cam, and you're going to be rotating a full 360 degrees. So that means we need 12 segments, and I'm going to use 10 mm as my measurement across for the displacement diagram. You can use any measurement, it doesn't matter as long as they're equal. The height of your displacement diagram, so that's the base of it. The height of it is given in the question. So it said from 0 to 120 your rise is 40 mm, then there's a dwell and then a fall of 40 mm. So the highest point is going to be 40 mm. So measure up 40 mm, and that's the highest point. Okay, so draw across your 40 mm height and draw all your lengths up to that point. Labeling on this displacement diagram, it is starting at 0 degrees, so we have 0 degrees here, and we're going to divide up our circle into 12 segments, so it's going to be every 30 degrees, so divide up 30, 60. So label your displacement diagram with every 30 degree interval, so that's 30, 60, 90 and so on. Okay. Before we divide up the cam over here, we're going to put in the displacement diagram first. I'm going to zoom in on that now. Now this is our displacement diagram, and we labelled it from 0 to 360. Now let's look at the question. It went from 0 to 120 with a rise of uniform velocity. So uniform velocity is just a straight line. So from 0 to 120 went up to the top here with uniform velocity. So that's just a straight line. So I'm going to put in lightly first and do the full displacement diagram, and then we can draw this around. Dwell from 120 to 180. Dwell just means it retains the same height. So the height there was at 40, it remains at 40. So it just goes a straight line across on the top. Next then, you had from 180 to 360 a fall with simple harmonic motion. Now, simple harmonic motion, let's see, do we have enough segments? 1, 2, 3, 4, 5, 6, perfect. With simple harmonic motion, we need to draw a semicircle with a radius of half whatever height the fall is, so in this case 40, so we need to draw a semicircle right on the edge here and divide it up 30/60. Now what that does is it gives you heights. Gives you a range of heights here. What you do is you bring those heights to the corresponding line. So starting off this point here, that would be our height there. Next point here represents the height in that line. This point represents the height there, and so on and so forth until you reach all the way along the bottom. This is our next height, it goes to our next line. That means this is your point here. So you're just bringing them straight across here to the left hand side. And now you join them all in lightly, and you'll get a freehand curve, kind of in an S shape. One way to remember simple harmonic motion is it will be slightly in a kind of an S shape, and that's the displacement diagram done. So our point for 0 is here, our height for 30 is there, our height for 60, 90, 120, 150, 180, and so on. So I'm going to draw that in strong now. Now once you have the displacement diagram done, it's only a matter of translating those heights over to the cam. So we divided up 30/60, we got 12 segments, now we need to do the same over here on our cam. And by labeling it, you can see exactly what height corresponds to which line. So if this is my 30-degree line, and that's the height for the 30-degree line, I'll bring that height right over here to the center. So bring that height straight across there, and rotate it down around the center to find the height. The 30-degree line here. And that's the first point. Now remember, it's moving anti-clockwise. So your cam is moving this direction. So the first line to hit off the inline follower will be this one here. That's why we start labeling clockwise. Do the same with the rest now for the uniform velocity. Bring your height over. Rotate it down. That's your next point. And do the same with the rest. Now this one, the dwell is going from 120 to 180, so it is on the 120 line, it is on the 150 line, and on the 180 line. So it's going to be a portion of a curve. Now these are the heights for our simple harmonic motion. That's the height for the 210 line, so that's my point here. This should be the height for, yeah, it's the height for the 240 line. So bring it down to 240 line, and so on. Once you've found all your points, you can join them all now, join them all lightly freehand and go over it again. Okay, that is part A of that C4 dynamic mechanisms question done. My past couple of videos have been a bit jumpy when I've been recording, so I hope that wasn't too jumpy. And that's the CAM question done. So I hope that helped. If it did, leave a like. And don't forget to subscribe to see more ordinary level and higher level DCG tutorials. Okay, thank you.